welcome to the deep dive. So you've given us this really interesting mix of sources, strategy docs, case studies, even some biography.
Yeah, quite a stack.
And our mission today really is to use this deep dive as a shortcut. We want to understand how these big tech ecosystems get built.
Right.
And we're doing that by looking at this idea of a Rainmaker connecting mobile payment standardization in China like a decade ago.
With the huge global AI chip supply chain competition happening right now, it's quite the thread.
It really is. So, okay, this source material, it's not just tech specs, is it?
No, not at all. That's what's great. It's about sales strategy, ecosystem building, real coordination. We've got case studies, actual sales memos, high-level decks.
Okay.
And they show pretty clearly that the kind of complex ballet needed to get mobile payments working in Asia, that same kind of deep coordination is absolutely vital for dealing with the AI chip value chain today.
Right.
It's, incredibly fragmented.
Okay, let's jump right in then. The central figure here is Karl J. Weaver, also known as
Karl
in Asia.
That's him.
So we need to define this term Rainmaker. It sounds like more than just a top salesperson.
Well, much more. Yeah. The sources are clear on this. A Rainmaker isn't just hitting quotas. They're actually changing the whole market landscape.
How so?
Well, they're like a marketing guru, a strategic evangelist, and a deal closer all rolled into one person.
Okay.
And their critical job, the real magic, is fusing the interests of stakeholders who seem totally disconnected. Think manufacturers, banks, mobile carriers.
Right, getting them all on the same page.
Exactly, to scale up a whole ecosystem, connect all the essential players, and really push that technology across the adoption chasm.
And what's striking about Weaver's story from these sources is that his main tools weren't like massive R&D budgets or huge marketing campaigns.
No.
It was cultural fluency and public speaking. That seems to be the foundation.
It's absolutely the bedrock. Look, Weaver, born in Massachusetts, right? But he commits totally to this idea of the Pacific Century. He goes and studies Mandarin Chinese in Taiwan.
For how long?
From 1982
until 1985 at National Taiwan Normal University, and then worked in the microcomputer motherboard manufacturing industry from 1985 until 1992, 7 years.
A whole decade.
Wow.
It's totally fluent. But think about doing business entirely in Chinese. As a foreigner back in the 1980s.
Almost unheard of.
Incredibly rare. And it built, immense trust. People saw the commitment.
And it wasn't just the language, was it? The sources mention he learned traditional characters first for Taiwan.
Right, the standard there.
And then had to basically relearn simplified characters just for mainland China. That shows dedication.
It really does. It shows he was serious about breaking down every single communication barrier. That cultural deep dive became his edge.
Okay.
But he paired that cultural knowledge with just relentless public speaking. Evangelism, really. The notes say over 300 mobile tech presentations globally since 2003.
300 talks. Okay, but how does that connect to today? Why is public speaking called his best tool when we have, LinkedIn, email, everything digital?
Yeah, seems counterintuitive, maybe. But think about trying to reach a top executive today. A cold call. A blind email.
Forget it.
Exactly. The success rate is abysmal. Like less than 2% maybe. People see it as intrusive. There's malware risk. It just doesn't work well.
Makes sense.
But public speaking and then amplifying that content, putting the talks on YouTube, sharing insights on LinkedIn that positions you differently.
As a thought leader.
Precisely. You're sharing knowledge, you're guiding the trust process, you're making really complex tech understandable, maybe in multiple languages, and you're laying the groundwork for deals before you even have the first meeting.
Strategic trust building.
Yep.
At scale. Okay, let's make this concrete. Let's look at that classic chicken and egg problem he faced at Gemalto in China. This was 2008 to 2013.
That's the period, yeah.
And the mission was promoting these SWP NFC USIM cards for contactless mobile payments.
Right, and this was a proper nightmare, technologically, politically, coordination-wise. The goal, standardized mobile payment.
Okay.
And the core tech was that SWP NFC USIM card. Now, the key detail here for you listening is the USIM part. The secure element the chip needed for payments. It wasn't in the phone itself.
Okay. Where was it?
It was embedded in the SIM card. The USIM.
Which means
the mobile operators, the carriers, they had control. And they could ensure security standards were met. That was crucial.
Okay, so to get this launched, you needed buy-in from who? Phone makers, the OEMs?
Yep. The big three carriers, China Mobile, China Unicom, China Telecom.
And the money side.
Absolutely critical. The major banks and the big one, China Union Pay. Everybody had to play ball.
And that's the chicken and egg, right? Why wasn't it happening?
Because it was crystal clear. The carriers, they didn't see any immediate money in it. Short-term benefits, zero. The banks weren't going to build out the payment infrastructure, the terminals, unless loads of people were using it.
Naturally.
And the phone makers weren't going to bother designing NFC into their phones until they knew there was a market, until the carriers and banks were ready. Nobody moves first. Stalemate.
So just promising future profits wasn't enough to break that logjam. How did Weaver actually solve it?
He used his platform. Public speaking, face-to-face meetings. But he changed the psychology.
How?
He didn't just sell the benefits. He hammered home the risk of delay, the fear of missing out, of losing market share if they didn't move.
The FOMO angle.
Kind of. By presenting this clear, standardized path forward, the FLAP NFC USIM approach, he made them realize that if they didn't get on board together, and now,
they'd be left behind.
Exactly. They risked becoming irrelevant as mobile commerce took off anyway. And that fear of being displaced, communicated clearly, fluently in their own context.
Yeah.
That was way more powerful than some vague promise of future profit.
That's fascinating. A real insight into strategy. And there's that story in the sources about China Mobile trying to go it alone, wasn't there?
Yes. That's a great example. China Mobile, the biggest carrier by far, they tried to bypass all this coordination, develop their own proprietary mobile wallet. Total failure, complete flop, because of a really basic technical issue.
Oh, what's it?
Bad signal quality. They apparently put the antenna in the wrong place in the phone or SIM setup. Just didn't work reliably.
Oh, wow.
And Weaver, who'd been preaching this standardized, coordinated approach, he basically saw it coming. He understood the integration challenges.
So their failure kind of proved his point.
It was a huge public validation that coordination and standardization his way was the only path that actually worked. It really helped bring the others around.
So that's when things started moving.
That was the tipping point. ZTE, HTC,
Yeah.
they started making phones with the standardized SWP NFC USIM tech built in. That put huge pressure on the other operators. And then China Unicom started making custom phones based on Gemalto's USIMs. And boom, the ecosystem was basically locked in. He connected all the dots, got everyone across the chasm.
Okay, incredible story. So let's pivot now. That was China. Mobile payments a decade ago. High stakes, complex, but ultimately a local ecosystem challenge.
Relatively speaking, yes.
So what does this Rainmaker strategy, fusing interests, evangelizing a standard meme for today? For this,
China is the powerhouse for OEM manufacturing, making the actual phones, the devices, and also huge in cloud infrastructure, building the massive data center server farms. Think Alibaba Cloud, Huawei.
Got it. Manufacturing and cloud infrastructure.
Right.
And the absolute core, the chip making, rests somewhere else.
Rests primarily in the rest of Asia. This is the critical hub. Taiwan is, well, it's the undisputed king of advanced semiconductor manufacturing.
TSMC.
TSMC, the world's biggest foundry. They have the leadership in the really cutting edge stuff, the 5 nanometer, the 3 nanometer nodes. Nobody else can do it at scale.
And other Asian players.
Crucial too. South Korea is essential for memory chips. Samsung, SK Hynix, and Japan provides irreplaceable high-tech materials.
Yeah.
Things like photoresist, specialized chemicals, the secret sauce needed for advanced chip making.
So it's a truly global chain. You break one link.
The whole thing grinds to a halt, exactly.
Okay, looking at the competitive dynamics now, the sources flag something really interesting. The rise of these super competitive Chinese large language models. We should talk about DeepSeek.
Yeah, DeepSeek is definitely making waves. Specifically, their V3 and R1 models. They're open source, which is significant.
And how good are they?
Apparently very competitive, holding their own against major US models like OpenAI's O1 series in terms of capability.
But that's not the main story, is it? The sources mention cost.
That's the disruptive part, the cost. The sources suggest DeepSeek is dramatically cheaper to run, like 1/10 the cost of comparable US models.
That's a massive difference. How are they achieving that? Is it just cheaper labor or something?
No, it seems to be architectural innovation. Primarily, they're using this technique called mixture of experts, MOE.
Mixture of experts. What's that?
Okay, so instead of having one giant, incredibly dense AI model trying to do everything,
Right.
MOE uses multiple smaller, specialized submodels. Think of them as experts for different parts of a task or query.
Like having a team of specialists instead of one general practitioner.
Exactly like that. So only the relevant experts get activated for any given task. This massively cuts down the amount of computation needed.
Which means less processing power, less energy.
And dramatically lower cost. It's a very clever approach.
And this drive for efficiency for lower cost, that feeds directly into the push for edge computing, right? The Gene AI smartphone.
Absolutely. That's the whole trend. Get the AI computation off the distant cloud servers and run it directly on your phone, on the device itself.
AI at the edge.
AI at the edge. And the benefits for you, the user, are potentially huge. Faster responses, no network lag, better privacy. Your data doesn't necessarily have to leave your phone.
And battery life, AI sounds power hungry.
You'd think so. But running it locally can actually be more power efficient than constantly sending data back and forth through the cloud. Especially for things like computational photography, real-time translation, tasks that happen right there.
Makes sense.
That's why the new flagship phones, the Samsung Galaxy S24 Ultra, the upcoming Apple iPhone 16 Pro, are all touting their on-device AI capabilities. It's the next big thing.
But relying on this incredibly specialized, globally fragmented system creates massive geopolitical risks, doesn't it?
Yeah.
Which brings us right back to Taiwan.
It's the elephant in the room, the ultimate flashpoint. The world's over-reliance on TSMC in Taiwan. It's a profound supply chain risk. Affects everyone. Apple, Nvidia, AMD, even Chinese companies like Huawei.
And we're seeing the impact already. Huawei's latest AI chips, the Ascend series, they're not being made at TSMC, are they?
No, they can't access TSMC's most advanced processes due to U.S. sanctions, so they're using SMIC, the Chinese foundry.
And the sources mentions S was using the M+2 process. What does M+2 actually mean for performance, and what's the real-world consequence?
Okay, M+2 basically means SMIC's technology is roughly 2 generations behind TSMC's state-of-the-art. They don't have the most advanced manufacturing equipment, specifically the EUV lithography machines needed for the tiniest transistors.
And the consequence of being 2 generations behind?
It's about efficiency, or rather inefficiency. The sources talk about yield limitations. Maybe you're on 20% yield.
20%? That sounds terrible.
It is. A 20% yield means for every 5 silicon wafers they process, they have to throw away 4 because of defects.
Wow.
Think about the wasted materials, the wasted time, the huge extra cost baked into every single functional chip they produce. It makes it incredibly difficult for Huawei to scale up production and compete on cost or volume globally.
So this intense tech race, the geopolitics.
Yeah.
It's fascinating, but the sources also highlight this other massive challenge looming over everything, the environmental cost.
Yeah, you can't ignore it. The energy demands are just staggering.
Staggering seems like the right word.
This is where a new kind of Rainmaker strategy might be needed, focused on sustainability standards. Look at the forecasts. AI data centers globally needing 90 trillion watt hours of electricity by 2026.
90 trillion. How much is that?
Okay, for context, that's roughly the entire annual electricity consumption of a country like Germany.
Just for AI data centers.
Just for AI data centers. And it's 10 times what they used back in 2022. The growth curve is almost vertical.
That's sobering. And you see it in everyday use, too.
Oh, yeah. Think about it. One ChatGPT query. It uses somewhere between 50 and 90 times more electricity than a simple Google search.
50 to 90 times.
Because generating complex text takes vastly more computation than just fetching a link. So the carbon footprint of every AI interaction we have is exponentially higher.
And it's not just energy, is it? The sources mention water usage in chip manufacturing.
Water is absolutely critical, specifically ultra-pure, highly filtered water. They use it for constantly cleaning the silicon wafers during production.
How much water are we talking?
Modern chip fabs, these giant factories, can use millions of gallons a day. It's a huge amount.
And that's creating its own challenges.
For sure. There are those rumors mentioned in the sources about TSMC potentially exploring building a massive desalination plant, like down in Baja, California, near the Sea of Cortez.
Desalination, to make fresh water from seawater.
Yeah, and then potentially piping that water hundreds of miles across the border up to their new factories in Arizona.
That sounds incredibly expensive and complex.
Immense. It just shows the sheer resource intensity needed to stay at the bleeding edge of this technology. Adds another layer of complexity to this whole global coordination puzzle.
Okay, let's try to wrap this up and bring it back to you, our listener. What's the core lesson here?
I think the fundamental takeaway, whether you're looking back at those NFC payments in 2013 or at Gen AI chips right now, is that disruptive technology doesn't just happen. It needs that Rainmaker figure. Success really hinges on someone stepping in, someone culturally fluent, persuasive to bridge all those competing interests.
Whether it's banks and carriers back then,
or global foundries, AI designers, and national governments today, someone has to connect the players, standardize the approach, and guide that adoption process. That's the key.
Yeah.
And understanding that whole complex chain from Taiwan's fabs to China's manufacturing scale to US algorithms, and then being able to communicate the opportunity, build trust, often in the local language. That's the differentiator. The AI opportunity is huge, yes, but the challenge is geopolitics, environment. They demand that kind of coordination and standardization more than ever.
So we've spent this deep dive talking about the power of the human element, Karl Weaver's personal touch, his cultural fluency, the impact of hundreds of speeches and scaling mobile tech.
Right, that personal evangelism.
But here's the final thought for you to consider. As generative AI gets better and better at communication, at creating convincing text, images, maybe even conversations, what happens to the power of that personal, bilingual, human evangelist in the next big tech revolution?
That's the million-dollar question, isn't it? Can an AI truly replicate the trust built over a decade of cultural immersion and face-to-face dialogue?
We might find out sooner than we think. Thanks for joining us for this deep dive.